Good evening students, welcome to basic electrical lectures and it is class number 8. In class number 7 we have covered series RLC circuit. So after that another 3 circuit is left, that is parallel RL circuit, parallel RC and then parallel RLC circuit. So these circuits are very much required only for problems and problem analysis. Okay, they won't ask any theory questions on parallel RL, RC and RLC circuits, but it is required while solving problems on parallel combination, series parallel combinations. So only for problem purpose we are studying only the what is relevant to the problems, only that portion we are going to study in parallel circuits. So we can start. So circuit number 7, that is parallel RL circuit. Parallel RL circuit. See, the circuit consisting of resistance and inductance are connected in parallel. The circuit consisting of resistance and inductance are connected in parallel across a supply voltage. Across the supply voltage. So it is called parallel RL circuit. See, we know that in parallel the concept is the voltage across resistor and inductor both will be same, because parallel no, voltage should be same. So you can consider current in resistor is IR, current flows in inductor is IL. Addition of these two currents you will get supply current. This is our basic concept. In parallel the branch currents are added together to get the supply current. Okay, what is the concept? Voltage is same in parallel. What is the different thing? Current. By adding all the branch currents, you will get supply current. See, don't study detailed analysis of this. How to write phasor diagram for this? That is much more than sufficient. See, now look at here. So, in parallel circuit, you have to take voltage as reference. Okay. In series circuit, take current as reference. Okay. So now I am taking voltage as reference. So with respect to voltage, what is current flowing through the resistor? If the reference is voltage, current flowing through the resistor in phase with the voltage. Because of resistance, current will be in phase with. So what is this phasor? Current phasor. Current in resistor, that is IR, is in phase with the voltage. Next, what about current flowing through the inductor? If the reference is voltage, what about current flow through the inductor? With respect to voltage, current flow through the inductor lags by 90 degree. So current flowing through the inductor lags by 90 degree. Now the vector addition of IR and IL, which gives supply current I. So the vector addition of this IR and IL, okay, we are going to give supply current I. Now the angle between voltage and the current is called power factor angle or phase angle. Okay, got it? See, for a parallel RL circuit, so what is the current triangle you got? Current triangle is IR, IL and I. So this is current triangle. So parallel RL circuit, this will be the current triangle. So current in R phase, current in inductor and the supply current. Angle between them is pi. Okay, got it? So that is about current triangle. So now another concepts are there that we can do it on the problems only. One more, that is another concept is admittance concept. Okay. So admittance concept is nothing but reciprocal of impedance. Reciprocal of impedance. So impedance will have two components. One is resistance. Impedance, the components of impedance are resistance plus or minus reactance. Plus or minus reactance. Plus reactance is inductive reactance. Minus reactance is capacitive reactance. These are the possible components of impedance. If I take reciprocal of this, if I take reciprocal of impedance, then it is called admittance. Okay. So now if I convert this into admittance, then 1 upon reciprocal, the component of admittance or conductance, plus or minus susceptance. Okay, got it? So minus for inductive susceptance, plus for capacitive susceptance. So this concept, okay, I will explain while solving the problems. Okay, it is not much important. Okay, in impedance, in impedance form only we can do all the problems. Okay. So now this is about parallel RL circuit. You just remember how to draw the phasor diagram. That is more than sufficient. So next, parallel RC network. So pause the video and then copy down. So parallel RC network. So parallel RC network. So obviously the resistance, it consists of resistance and capacitance are connected in parallel across the supply voltage. It is called parallel circuit. Okay. So resistor, capacitor and applied voltage. What is current flowing through the resistor? IR. What is current flowing through the capacitor? IC. Vector addition of IR plus IC. What you will get? Supply current. See, in AC, keep in mind vector addition. Don't do direct addition. That is not correct. Okay. So the vector addition we can give like this. I is equal to IR plus IC. Addition of these two currents will get supply current. So this is also called vector or phasor. What is the reference? Voltage is the reference, because parallel circuit, take voltage as reference. Now, by knowing voltage, determine current flowing through the resistor. Current flow through the resistor in phase with the voltage. Okay. Current flowing through the resistor is IR, is in phase with the voltage. Next, what is current flowing through the capacitor with respect to voltage? See, if the reference is voltage, what is the current flowing through the capacitor? Leads by 90 degree. So the current flowing through the capacitor leads by 90 degrees. Okay, current flowing through the capacitor. Now, join these two vectors. Joining these two vectors, so you will get a resultant current. So that current is I, nothing but supply current. The vector addition of IR and IC will give resultant current. What is this? What is the angle between voltage and the current? Okay, that is called power factor angle or phase angle. Okay, got it? So this is the phasor diagram for parallel RC network. See, if I use the impedance admittance concept, the parallel circuit get converted to series circuit. Okay, that is, don't go for that conversion. You can do it directly in this way itself. Okay. So if you study more, it leads to confusion. You stick on to one particular concept. Okay. So by that we can solve. Next is parallel. Say this is current triangle. Okay. I, IC and IR. This triangle is called current triangle. Okay. Because in parallel currents are added. Vector addition. So this is circuit number 8. Parallel RC is circuit number 8. Next one is last circuit. That is parallel RLC network. Okay, parallel RLC circuit. Parallel RLC circuit. So how the circuit will be? So it consists of resistance, inductance and capacitance. All are connected in parallel across the supply voltage V. Okay. What is current flowing through the resistor? IC? No, IR. Okay. IR. What is current flowing through inductor? IL. What is current flowing through capacitor? IC. Okay, IC. So I will see. Okay, then look at here. This is a supply current I. See, now we have to draw phasor diagram by taking three conditions. What we done in series RLC circuit. Now case 1. Okay, case 1. When inductive reactance is equal to capacitive reactance. Now under this condition, we know that, look at here, we know that what is voltage across inductor in general? I into XL. What is voltage across capacitor? I into XC. But here, voltage across inductor and capacitor will be same. But current flowing through inductor and capacitor will be different. Because due to different inductive reactance and capacitive reactance. However, for this condition, we have taken same inductive reactance, same capacitive reactance. Now, look at here. I am taking voltage is constant, then I am modifying IL into XL. Voltage is constant for parallel circuit. So, IC into XC. So, from this, what I will get IL V by XL. What I can get IC V divided by XC. Now, take some typical values. So, take voltage 100 volt, XL 5 ohms and XC 5 ohms. XC also you take 5 ohms. So therefore, if I take XC 5 ohm, V 100. So what you will get? 100 by 5. How much? You will get 20 ampere. Current flowing through the inductor. Current flowing through the inductor. What is reference? What is the reference? Voltage. Lags by 90 degree. So current flowing through the inductor, if the reference is voltage, you write minus J. You write minus J 20. Then what is current flowing through the capacitor? Voltage is 100. What is capacitive reactance? 5. 100 by 5 is 20. With respect to voltage, current flowing through the capacitor leads by 90 degree. So you should write plus J 20 ampere. We can draw the phasor diagram. What is the reference? Voltage is the reference. Now, current flowing through the resistor in phase with the voltage. Current flowing through the resistor, okay, that is IR, in phase with voltage. Then, what about current flowing through the inductor? Current flowing through the inductor lags by 90 degree. See, look at here. What is the magnitude? Minus J 20. Minus J comes this side. Then what about current flowing capacitor? Leads the voltage by 90 degree. Okay, plus J means in the electrical engineering, the phasor is rotated 90 degree in anti-clockwise direction. So what is this? Capacitor IC. But the inductor current and capacitor current are equal and opposite in sign. Therefore, these two currents IC and IL will get cancelled. Okay, will get cancelled. What is left now? Only this part. We left only this circuit. When inductor and capacitor get cancelled, what is the current flowing through the circuit? Only IR. Supply current itself IR. Okay. Therefore, at XL is equal to XC, the above phasor diagram represents pure resistive circuit. So the parallel RLC circuit at XL is equal to XC becomes pure resistive circuit. It is also called in-phase circuit. And the circuit is at, the parallel RLC circuit is at resonance condition at XL is equal to XC. At resonance, what is the power factor? Unity. Why unity? Because the angle between voltage and the current is 0 degree. Okay. What is cos 0? 1. Power factor nothing but cos pi. Cos 0 is 1. So at resonance, power factor will be unity. Whatever I explained, you make a note point. Okay. Note point. And then write down in sequence. So refer series RLC circuit at this condition what I give a note. So refer that notes and write it down here. Okay, got it? But you write related to this parallel circuit condition. See, next pause the video and then copy down. Next, look at here. What is the another condition? Now, this is very important. Now, inductive reactance is more than capacitive reactance. So now I will take XL, I will take 10 ohms. XC, I will take 5 ohms. We know that what is current flowing through the inductor formula? Okay, V by XL. What is current flowing through the capacitor? V by XC. Okay. So, what is the voltage? 100 volt. What is XL? We have taken 10. 100 by 10, 10 ampere. Inductor current, na, you write minus J. Minus J, because we are taking reference as voltage, because we are analyzing parallel circuit. The next voltage you take 100, XC 5 ohms. So you get how much? 20 ampere. But capacitor, with respect to voltage, capacitor current lead by 90 degree. So you write plus J. Now you can easily draw the phasor diagram. Okay. Now which one is dominating? Inductor or capacitor? Capacitor is dominating. See, if XL is more than XC, capacitor is dominating. Why means, look at here. Capacitive reactance is lesser, capacitive current will be increasing. See, higher the reactance, lesser will be the magnitude of current. Lesser will be the magnitude of current. We can draw the phasor diagram. So what is the reference? We should be very careful. Okay, reference is voltage. Then what is the current flowing through the resistor? In phase with the voltage. That is IR. What is current flowing through the inductor? Minus J 10 ampere. So this is minus J 10. Okay. Or simply you write current flowing through the inductor. What about magnitude of current in capacitor? Plus J 20. So plus J 20, you should write double of this. Okay. So capacitor current leads the voltage by 90 degree. Which is having largest magnitude? Capacitor current or inductor current? Capacitor current. Okay. Therefore, the resultant falls on inductor side. Therefore, the resultant falls on inductor side. Okay. So that's why you should write IL minus IC. Don't write IC minus IL. Don't write IC minus IL. Just look at here, guys. Just add those inductor and capacitor currents. So look at here. IL plus IC. Simply add. We have taken typical values. What is IL? We got minus J10. Okay. Plus. What is the capacitance value we got? Okay. Plus J20. Minus J10. Okay. Plus into plus plus J20. Simplification gives what you will get? Plus J10. You will get plus J10. So the resultant falls on capacitor side simply by adding this. Okay. So now look at here. Joining this vectors. Okay. Resultant vector IL minus IC and then IR. You will get a supply current is how much? This is the resultant current. That is called supply current. Vector addition of all this gives supply current at this condition. Now the angle between voltage and the current is power factor angle pi or phase angle pi. Okay, got it, guys? How to write the phasor diagram? So next is XC more than XL. Pause the video and then copy down. Please pause the video and then copy down. So case 3, XC more than XL. Now take capacitive reactance 10 ohms and inductive reactance 5 ohms. Values are only for understanding purpose. In exam, don't write. So now calculate IC. Next calculate IC V by XC. 100 divided by 10. So we got 10 ampere. Capacitor now plus J10. Okay. What is IL? V by XL. So 100 by 5. Inductor now you write minus J. Okay. For current you write minus J. Because current defines with respect to reference. Reference is voltage. See now, draw the phasor diagram. Reference is voltage. Okay. So current flowing through the resistor is IR, is in phase with the voltage. Then next, what is current flowing to the capacitor? Leads the voltage by 90 degree, that is IC. Why I written lesser magnitude? Because only 10 ampere lies on plus J axis, but minus 20 ampere lies on imaginary axis. So what is current flowing to the inductor? With respect to voltage, current flowing to the inductor lags by 90 degree. So IL, current flowing to the inductor, lags by 90 degree. So now, which one is dominating? See, XC is more than XL, but inductor is dominating. So the resultant addition of this two falls on inductor side. Okay. So simply add those minus J20 plus J10. What is the resultant? Minus J10 ampere. Okay. So addition of those two, you will get, okay, IL minus IC. Do the vector addition of these two components, then you will get a supply current I. Supply current I. The angle between these two is called power factor angle or phase angle. Okay, got it? So give the namings OEAB. All power triangle, admittance triangle, impedance triangle, everything I will explain while solving problems. So follow any one concept, admittance concept or impedance concept. So impedance concept is very easy. Okay. See, impedance concept holds very good for series circuit. For parallel circuit, admittance concept holds good. But however, parallel also you do it in impedance method only. Okay, follow any one method. So guys, next I will revise all these 9 circuits. So we covered all the circuits, R circuit, L, capacitive circuit, RL, RC and RLC, both series and parallel, together totally 9 circuits. See, the problems will be very simple. Okay, what is importance you need to take care while solving problems is operating of calculator. If you know calci operation very well, you will get full marks in single phase AC circuit. Rest everything is formulas. For all the circuits, formulas will be same. For all the circuits, formulas will be same. See, now I will list out the formulas. So in the next video, I will upload problems. So before copy down the problems, you just list out what are the formulas I am giving now. Okay. So formulas is very important. Okay. Compulsory formulas. Okay. Compulsory formula. If there is any spelling mistake, please kindly adjust. The word what I written is compulsory. Compulsory formula. Okay. Whatever the circuit it is, R circuit, L circuit, capacitor circuit, series RC, series RL, parallel series RLC, parallel RL, parallel RC circuit and parallel RLC circuit, whatever it may be. Our equation is VI cos pi, reactive power is VI sin pi and apparent power is V into I. See, all these 3 formulas are applicable to RC, RL, RLC, or parallel RC, RLC and RLC. Okay. So for all this circuit, this formula holds. While solving problems, keep in mind all these quantities, voltage and current, keep it in RMS value. Keep it in RMS value. RMS value only. Keep it in RMS value only. Then, so what is this pi? Pi and pi. This is called phase angle. This we can call it as phase angle. Means angle between voltage and current. Angle between voltage and current. Where is the voltage? This is the voltage and this is the current. The angle between these two quantities, you should write it here. Okay. Keep the calculation in degree mode, then solve it. You will get PQS values. Okay. Now only resistive circuit. Power formula is VI. Pure inductor, power never consumes power. Pure capacitor never consumes power. 99% problems they are going to ask with this combination. RC, RL, RLC may be series or parallel or combination of both, series parallel. So for all such combinations, these three power equations will remain same. Next, another thing, you must remember the power factor formula. What is power factor formula? Cos pi. Okay, by using phase angle you will get direct power factor. From voltage values also we can calculate power factor, that is VR by V. From impedance triangle, what is the power factor? R by Z. From power triangle, what is the power factor formula? P by S. What is P? Real power, true power, average power. Okay. What is S? Apparent power or total power. You must remember this power factor equation. Okay. Got it? Now, if it is RL circuit, impedance is R plus JXL. If it is series RC circuit, impedance is R minus JXC. If it is RLC circuit, impedance will be R plus JXL minus JXC. Okay. Whenever we have capacitance, impedance, you write minus J. Okay. Whenever we have inductor, you write inductive reactance with plus J. Now see, resistance, inductance plus J, capacitance minus J. Okay. So remember this. This is all valid for series. Okay. If I asked in parallel, actually I should teach admittance concept. Okay. Don't mess up with lot of concept. Follow any one method. Now R and L, you have to represent in impedance only. Now what is the impedance for resistance? R plus J0. Okay, over. Then what is the impedance for inductance? Okay, there is no real part, only inductor, no real part. 0 plus J XL. So this will be one impedance, let us call Z1. This will be another impedance, Z2. Now the two impedances. This is Z1 and Z2. Both are connected in parallel. So this gives effective impedance. So like that you can solve the problems. Okay, got it? So guys, this much equations are sufficient to solve any combination of problems on single phase AC circuit. So these formulas VI cos pi, VI sin pi, VI, it works same for all these circuits. Even though combination of this like this, inductor, resistor, capacitor. See, for this circuit also same power equation, VI cos pi, VI sin pi, VR. So okay, there is no separate formula for different types of circuits. Okay, for all such circuits these are the equations. So please strong with all these equations. Okay, whenever you are solving problem on AC circuit, you write all these formulas in the rough sheet, means in exam last page of the booklet, and you keep on applying the formulas from the given data. Definitely you will get a solution. Okay, later I will teach how to do cross verifications and all in solving problems. Guys, like the video, share and subscribe, tell your friends. Okay, watch the videos regularly. In the next video I am going to upload problems. Okay, totally 3 to 4 parts I am going to upload problems on single phase AC circuits. It covers all examination problems solved. Whatever I explained in the video, just copy down in your notebook and just go through that. Okay, so have a nice day, take care, bye bye.